any of them. Okay. All right, so we'll try to look at exercise 1E. Exercise 1E of what text is that? That's your Cambridge Pure Mathematics. So let's do number one. Let's do 1E. I'm just trying to establish the technique. It says x squared, x to the power of 4 minus 13x squared plus 36 equal to 0. So we're required to solve that. Okay, which we have also done. Okay, I'll be fast with that. And now, to use this technique, the first thing you must take note of is this. Remember that for a quadratic, what you have is x to the power of 2 as the highest power available. So you need to do some manipulations to make us have to the power of 2. So how do you do that? You can now say that because to use this technique, you must have x to the power of 4. If you have x to the power of 4, x to the power of 2, you can use this technique. If you have x to the power of 6 and x to the power of 3, you can use this technique. If you have x to the power of, let's say, 9 and x to the power of 3, you can't use it. So you need to understand when you can use this technique. So I'll say let y be equal to x to the power of 2. So this will now be like, so I'm going to come back to write this as what? X to the power of 2 or x to the power of 2 from one of our lot of indices minus 13 x to the power of 2 plus 36 equal to 0. So where I have x to the power of 2, I will put in what? Y there. So that will be y squared minus 13y plus 36 equal to 0. At this point, you can just simply apply your knowledge of factorization of quadratic equations to solve this. Remember that the reason it's called complex quadratic equations is because we just need to introduce a new idea that will help us simplify the problem. So from here, you're going to have that what? I have negative 13, I have 36. This is positive. It means that the two factors I'm looking for must both be what? Positive, must both be what? Either negative or both positive. How do I confirm that? This is negative, so I will need both to be what? Negative. Now the next thing I check, this is even and this is odd. It will mean that both factors I'm looking for, one has to be odd, one has to be even. So I'll look at 36. Let's break 36 down. What am I going to have? I'm going to have y squared minus 9y minus 4y plus 36 equal to 0. If I multiply this, I'll get this. If I add this, I will get this. The reason I've gone straight is because the coefficient of y squared is 1. Whenever the coefficient of this is not 1, the is multiplying the first and the last term. Alright, so this will give me y into y minus 9 minus 4 into y minus 9 equal to 0, which means that y minus 9 into y minus 4 will be equal to 0, and then y will be equal to 9 or 4. But remember, that is not what we're told to look for. That was simply a way to solve the problem. It's not the end. So I would come again by using this technique. I'll divide my body into 2. And then I will say y equal to 9 and y equal to 4. What is y? Y is equal to x squared, and then y here is equal to x squared. So I'll make my substitution. These are x squared will be equal to 9, and x squared here will be equal to 4. Now, because the power here is to the power of 4, my answer definitely must be 4 values. So from here, x will be equal to plus or minus the square root of 9, and x will be equal to plus or minus 3. And from here, x will be equal to plus or minus the square root of 4, and x will equal to plus or minus 2. So I can say that x is equal to plus or minus 2, plus or minus 3. 4 values are expected at the end of the day. Alright, so let's go on to another one. So which one? Let's take key. Let's take, can you divide? Not divide. Okay, so let's take key because of the week. Or let's take L. Let's take L. So we're going to take L from that same text. Let's take L and let's see what happens. So exercise, we're still on exercise 1E. We look at question 1L. So question 1L, question 1L, question 1L. Question 1L. All right, it says 8 over x to the power of 6 plus 7 over x to the power of 3 equal to 1. So how do we handle a problem like this? Now, there are two ways you can solve this problem. You can choose to clear the denominator first before you solve, or you can alternatively just make a substitution for this and go right away. All right, maybe we'll just take all right, so let's take the easier one, which would be to multiply through by x to the power of 6, and that will give me 8 plus 7x cubed equal to x to the power of 6. So I'll have to rewrite this, and I'm going to have x to the power of 6 minus 7x to the power of 3 minus 8. What I've done is to move them all to this side and then write them on the left hand side equal to 0. At this point now, look at something shocking here now. Remember to apply that rule, there's something you need to do. Look at this, I can say this is x to the power of 2 or raised to the power of 3. Remember that the objective is to have to the power of 2. You're trying to make it resemble a quadratic equation. So somebody may argue, why not do this? Why not do it that way? Why not say x to the power of 3 or raised to the power of 2? All right, so let's see if that will work for us. Minus 7 x to the power of 3 minus 8 equal to 0. So let's see, because one of the things we do when it comes to math is to open up our thinking. Let's see if this will help our work. So I can say let y be equal to x to the power of 3. Wonderful enough, it works. So it means that y to the power of 2 minus 7y minus 8 will be equal to what? 0. So from here we can finish up. How do we solve this? This will simply be what? Now, remember that I said that the reason you're bringing this idea is not to learn quadratic equation, but to use it to help you generate the quadratic equation. And at this point, we're that you should be able to handle the problem by yourself. So this will simply be minus 8 minus 7. So it means that one factor I'm looking for has to be positive and one has to be negative. So this will be y, because the coefficient of y squared here is 1, minus 8 into y plus 1. Because the two numbers you can multiply to get 8, negative 8, and to get negative 7 will be such numbers that 1 will be minus 8 and 1 will be what? Plus 1. So when you do that, you're going to have that y will be equal to negative 8, rather y will be equal to 8 and y will be equal to minus 1. Alright, so we've done that part. What will be the next thing we'll do? Remember that we're not told to look for y. So I'll separate my board once again. And then I'm going to have that what? Y is equal to 8 and y is equal to minus 1. X to the power of 3 will be equal to 8 and x to the power of 3 will be equal to minus 1. Now, when you're dealing with cubes, you're either going to have either positive or what? Negative. You can't have positive and negative. So this will mean that x will be equal to 2. That's the only possible outcome for that. And here x will be equal to minus 1. So at the end of the day, we're going to have that what? X will be equal to 2 or what? Minus 1. And that should take care of that problem. And a lot of questions will be popping out in our mind. What about, how come we're having just 2 values for x when we expect to have like maybe 6 different answers? But that's the beautiful thing about maths. In this setup, x will be equal to 2 and x will be equal to minus 1. So in this setup, you can only have that x will be what? 2 and then x will be equal to 2 and then x will be equal to minus 1. But let's test. I hope that answer will be correct. Will that answer be correct? This will be 7 over 8. Is that not? 7 over 8. What would this give you? Finally, 1 over 8. Is that not? So 7 over 8 plus 1 over 8 will give you 1. I really check whether the answers are gotten are right or wrong, but it's always so good that you also check. But if you do your checks, you're going to have that. If you have minus 1, this will be 8. 8, this will give you a positive answer, 8 minus 7, and that will give you 1. So that means that what we have done is actually very, very correct. All right.